Hey guys, here's the final review for Chapter 7. We're going to be looking through not all of these problems. I'm going to kind of skip around a little bit. But these are the types of things that you can expect to go with exponential and logarithmic functions. First up, we've got a graph and exponential function. There are a couple things you might be able to tell just by looking at this. The first is that this is an exponential growth curve, so it should look like this. I'm not really sure why this guy stops there. That's kind of weird. The second is that we could make a table for this. If I plug in three values for x, and let's use -1, 0, and 1 for nice easy numbers, we get 2/3, we get 2, and we get 2 times 3 is 6. The only one of these that has those points happens to be graph C. In fact, that's the only one that even has 0, 2, and keeps going up when you get over to the right. For number 15, we've got a graph, a log graph. First thing you should know is that log graphs look like this for positive log bases. The only one of those that actually fits that curve is D. If you were so inclined, you might make this into a table, and what we're going to do for that is to rewrite this as 2 to the y is equal to x. I'm going to make an xy table plugging in -1, 0, and 1 for y. And for x values, we get a half, we get 1, and we get 2 as our possible values, all of which fit very nicely on graph D anyway. We've got to solve this equation, and here we're given things that are in different bases at the start, so we're going to try to make them into the same base. And by that I mean, I'm going to try to write 9 and 27 as some other power. I know that both of these can be written as powers of 3. So this would become 3 squared for 9 to the x plus 1, and 3 to the third for 27 to the x minus 1. Distributing my power to a power, we get 3 to the 2x plus 2 is equal to, and doing the same thing there, 3 to the 3x minus 3. If our bases are the same, that means our exponents must be equivalent as well. So 2x plus 2 is equal to 3x minus 3. Solving this equation, bring 2x over to the right side, we get 1x, and plus 3, x is equal to 5, which happens to be choice C right in front of me. Here we've got another problem. We have two exponential terms that we got to write in the same base. And just like before, well, these are going to be the base of 3. Looking at 9 to the -1 is the same as 1/9. I also know that 9 is 3 squared. This is kind of doing everything way more than I need to, but I could say 3 to the -2 is the same as 1/9. That side's done. I also know that 3 to the 3 is the same as 27. We still got the 7x minus 6 up there. I'm going to distribute that out. And we get 3 to the 3 times 7 is 21x. 3 times -6 is -18. So 3 to the -2 is going to be the same as 3 to the 21x minus 18. I'm going to set these equal to each other now that my bases are the same. -2 is equal to 21x minus 18. If I add 18 to both sides, we end up getting 16 is equal to 21x. Going up, because I'm out of room in the bottom, 16 over 21 is equal to x. And if I look at my answers, A, B, C, D, 16 over 21. For whatever number this is, 54, we're going to do some exponent combining first. So this is going to be 4, -2 plus x plus 1 plus 3 is equal to 4 to the 5th. I'm going to rewrite this in terms of just the exponents. -2 plus 1 is going to be -1 plus 3 is 2. So that's going to be x plus 2 is equal to 5. That means x equals 3. In solving this one, we're going to use some exponent rules. I've got all 3's on the left side here, so I'm going to add the exponents. So that's going to be 3, 2 plus 4 is 6, 6 plus 5 is 11, 3 to the 11 equals 3 to the x, and well, that comes out pretty quickly to be 11 is equal to x. For number 31, we're going to skip because this is not a problem that we have the math to do yet, and that's an accident of my part. That's why it's in there. For number 32, we've got log base 4 of x plus 3 is equal to negative 2. My strategy for this is I'm going to convert this to an exponential. There's my base, my answer, and my exponent. So 4 to the negative 2 is equal to x plus 3. And that's looking at base to the exponent is equal to an answer. And then from there we've got 4 to the negative 2 minus 3 is equal to x. That would be totally okay as an answer. If you wanted to do this out, you'd end up with something over 16. But this would be an acceptable answer for me. Next up, write the equation. Log base 64 of 256 is equal to 4/3 in exponential form. Okay, we've got our base, we've got our answer, we've got our exponent. This seems to be something we're using a lot. So 64 to the 4/3 is equal to 256. This is something that we shouldn't have to worry about getting right. Next up, we got number 40. We've got some money being deposited in an account. We've got to choose which one to select as our bank account. So starting at $2,500, we're looking at 4% average annual interest rate compounded quarterly. That's going to be the big thing to change this problem. Quarterly means 4 times a year. So let's take a look at what this is going to look like. So we got a starting amount, $2,500, multiplied by what we're thinking about as our scaling, whatever our interest rate is. And that's going to be 1 plus, and it should be 4%. But we're doing this 4 times a year, so we want to do this each time of those 4 times a year. 4% divided up into 4 times a year is going to be 0.04 divided by 4. I'm writing this way to help us see something. And then we got the same thing going on as far as time. If this was number of years, quarterly means I've got to consider 4 times as many things because we're looking at this at 4 times each year. If I were to simplify this, this might make a little bit more sense. We got 2,500, 1 plus, or 1.01. Does it make sense that 4% divided by 4 is 1%? To the 4t power. Okay, write an equation to model the amount of money in Bank B if you get 3.75% compounded continuously. Compounded continuously is kind of a stupid thing that we only use in math. As soon as you see the words compounded continuously, we're using a different formula. This is something we did not talk significantly about in class, and A equals PE to the RT is what that formula looks like. This is really great in biology where things actually multiply at a continuous rate. We're not really good in math because no bank is actually going to make this calculation. The things mean the same thing, but now we've got kind of our scale factors, that e to the r piece. And then looking at this, we're going to have A is equal to 2,500 times e to the 0.0375 t. After 10 years, which one has more money? Well, I'm going to plug 10 into both of these. So 2,500 times 1.01, and that's going to be 44 times t. And then we're going to have 2,500 times e to the 0.0375 times 10. Plugging these in, 2,500 times 1.01 to the 40, we get 3722.1593. And for my other lovely one, 2,500 times e to the power of 0.0375 times 10. And doing that, we get 3637.4785. This is obviously the better deal, and you've got about $90 more for our effort there. All right, I'm going to do one of the three of these. And that looks like number 57, because that looks a little bit more interesting. I'm not doing 55 or 56. How much money deposited now into an account paying? Okay, so this is P that we're looking for. 7% annual interest. R is equal to 0.07. Compounded yearly. Have a balance of $6,000. That's A, and that's T, 6 years. So we're going to have one. I don't know why I said 6,000. It's 1,000. So 1,000 is equal to P. That's what we don't know here. That's why it's a little bit more interesting. Times 1.07. And that's to the sixth. If I were to do that out, 1.07 to the sixth, we get about P times 1.5, and it's 0.007, so 1.501 maybe, is equal to 1,000. If I divide 1,000 by 1.501, we end up getting, ooh, that's fun, I ended up with something that wasn't what I typed in. There we go. You end up with P is equal to $666.22. For 58, we've got a piece of equipment. Oh, now we're dealing with depreciates. I think this is a good one for us to talk about. So it's depreciating. So costs, 85,000 new. That's going to be our PR investment. Depreciates, so negative 0.15 is equal to R. Find its value after 10 years. So we're looking at, for 58, A is equal to 85,000 times 1 minus 0.15 to the 10. So 85,000 times 0.85 to the 10th power is going to be 16,734. So after 10 years, it's going to be worth 16,000.